All right, so this example involves acceleration of a particle, and this is a part of your Learning Guide 7 Antiderivatives Learning Guide. So I'm going to start by reading the actual question here. It says the particle is moving along a line, and its acceleration is given by the function a is equal to 2 minus at, where t is greater than or equal to 0. They actually give you an initial condition here, and that is the velocity in 1 second is given by 10 meters per second. So the first part of this question involves finding the velocity time function. So remember this relationship here. If I take the derivative of a velocity time function, you get the acceleration function. However, we have the acceleration function and we want to go the opposite direction of a derivative, which we have called an antiderivative or the integral. Okay, so let's go ahead and do that first. I'm going to actually start with the function itself. So a is equal to 2 minus 8t, and I want to find the velocity function, so I'm going to take the antiderivative of this function. So I'm going to write it as v of t is equal to 2t is the antiderivative of 2 minus 8t all squared divided by the new exponent of 2 plus the initial velocity, so v naught. This acts as our constant. So remember, like I said in class, when you take the antiderivative, please don't forget the constant. So we actually can find that constant, but first off, I'm going to clean this up. I have v of t is equal to 2t minus 4t squared plus v naught. So I have enough information to find out what that actual constant is. I'm just going to move this down here. And that information comes from this sentence here. The velocity of 1 second at 1 second is 10 meters per second. So I'm going to use that condition to find v naught. So if my velocity is equal to 10 seconds, I could substitute 10 for v is equal to 2. And 10 meters per second, it happens at exactly 1 second, so I can replace t with 1. So I have 2 times 1 minus 4 times 1 all squared plus v naught, which is our constant, and that's what we're trying to find. So I have 10 equals 2 minus 4 1 squared, and that's easy enough to do. It's going to be negative 2 plus v naught. Therefore, my initial velocity is going to be equal to 12. So if I complete this, if I complete the actual function here, oh, sorry about that, I actually reversed it. V naught, therefore, my velocity time function is equal to 2t minus 4t squared plus our initial velocity, which we found to be 12. So there is my velocity time function given the acceleration function. I'm going to do part B in the next podcast.